Hello, 5th grade math students. Welcome to Chapter 14, which is all about three-dimensional shapes. In Lesson 1, we'll be exploring prisms and pyramids. Let's get started. So far in 5th grade math, we've only been discussing plane figures. Not plane, P-L-A-I-N, but plane, P-L-A-N-E, meaning flat or two-dimensional. Plane figures can be angles, or any closed figure made of a curve, circles, or any closed figure made up of line segments, such as triangles, rectangles, and other polygons. Before we move on to three-dimensional shapes, let's review a few of our polygons. Recall that a polygon has as many sides as vertices. For example, a triangle has 3 sides and 3 vertices. A square has 4 sides and 4 vertices. A rectangle also 4 sides and 4 vertices. Parallelograms and trapezoids also have 4 sides and 4 vertices. The differences between squares, rectangles, parallelograms, and trapezoids are in the arrangement of the lines, not the number of sides and vertices. A pentagon has 5 sides and 5 vertices. A hexagon has 6 of each, and an octagon has 8 of each. It is also helpful for us to review the idea of congruent figures before moving on to 3D shapes. Remember that congruent figures have the same size and shape. They can be superimposed on top of one another, and one would completely hide the other. For example, our 2 circles here could be placed on top of one another and appear as one object. However, the circle and triangle could not do the same. Our 2 triangles here could be superimposed over one another, but these 2 triangles cannot because they are of different sizes. Our 2 squares could also be superimposed over one another, but the square and the rectangle could not, because even though they each have 4 sides and 4 vertices, their line lengths are different, resulting in a different overall shape. Finally, before we delve in depth into prisms and pyramids, let's review some of the basic three-dimensional shapes. These solid shapes can include flat surfaces or curved surfaces. A cube has 6 flat surfaces. A rectangular prism also has 6 flat surfaces. A pyramid has 5 flat surfaces. A cone has 1 flat surface and 1 curved surface. A cylinder has 2 flat surfaces, 1 on each end, and then a curved surface. And a sphere has no flat surfaces and only 1 curved surface. All right, now that we've finished that quick review, let's move on to pyramids and prisms. A two-dimensional figure has only 2 measurements, length and width. Polygons are plane figures, but most of the objects around us are solid figures or three-dimensional figures. Those 3D figures have 3 measurements, length, width, and height. We describe solid figures or 3D figures by faces, edges, and vertices. Let's look at some examples. This is a cube. Its faces are flat surfaces. Each face is a square formed by 4 sides of equal length. The sides of each square are line segments. The cube also has 2 bases. The top and the bottom faces of a solid are called the bases. The base of a cube is also a square. Finally, a cube has both edges and vertices. An edge of a solid figure is a line segment formed when 2 of the faces meet. And a vertex is the point where 3 or more edges meet. You might also call it a corner. If we look at our cube, we can see that it has 6 faces, 12 edges, and 8 vertices. Now let's examine prisms. A prism is a solid figure with 2 parallel, congruent bases joined by rectangular faces. A prism is named according to the shape of its bases. Remember, congruent bases mean that the bases have the same size and the same shape. The bases of the prism we see here are rectangles, so this prism is called a rectangular prism. Any pair of opposite faces on a rectangular prism can be the bases. Let's take a look at all of the labels we have on this rectangular prism so we can understand what we're seeing. Our rectangular prism has 6 faces. 2 of those faces are the bases. But we have a front and a back, a right end and a left end, a top and a bottom. So 6 faces. There are 12 edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And there are 8 vertices, or 8 corners. 1, 2, 3, 4, 5, 6, 7, and 8. Let's look at another example of a prism. The bases of this prism are triangles. Remember, we name a prism based on the shape of its bases, so this prism will be called a triangular prism. Our triangular prism differs from our rectangular prism in that there's only one possible set of faces that can be the bases. There are only 2 parallel faces on the triangular prism, and those are the 2 that are colored purple. The other 3 sides are not parallel to any other side. So let's take a look at the parts of our triangular prism. We have 5 faces, top and bottom, and 1 of each of the triangular sides, correct? We also have 9 edges, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 6 vertices, 1, 2, 3, 4, 5, and 6. Apply what you've just learned to these 2 practice problems. In number 2, please name all the parts of the prism. Identify the shapes of the faces. And in number 3, explain why this figure is not a prism. There's a very specific reason. If you can't figure out what it is, go back and re-listen to the explanation of a prism a couple of slides ago. Press pause while you work, and when you come back, we'll take a look at pyramids. Now let's examine pyramids. A pyramid has one base, and that base can be any polygon. All of the other faces are triangles arising from each side of the base. The triangular faces share a common vertex. In other words, they meet at a point at the top. A pyramid is named according to the shape of its base. Since the base of this pyramid is a square, it's called, you guessed it, a square pyramid. Let's identify the different parts of this pyramid. First, there are 5 faces, 4 triangular faces, and 1 square face. The square face is the base. There are 8 edges, 4 where the base meets the triangular side, and 4 where the triangular sides meet one another. The 8th one is kind of hidden back here behind the one at the front, but it is there, I promise, to make 8 total. There are 5 vertices, 1 at the tippy top, where the 4 triangles meet to create the point, and 1 at each corner of the base. The base of this pyramid is a triangle, so this is called a triangular pyramid. A triangular pyramid has 4 triangular faces, including the base. There are 6 edges, 1 where each of the edges meets the base, and 1 where each of the edges meets another edge, to make 6 total. And there are 4 vertices at the corners of the bases and the edges, and at the point where the 3 edges meet. The faces of all prisms and pyramids are polygons. Now practice what you've learned about pyramids. In number 4, please name all the parts of the green pyramid. Identify the shapes of the faces as well. And number 5, please explain why this figure cannot be a pyramid. Press pause, and when you come back, we have yet another idea to explore. Let's finish up chapter 14.1 by learning about nets. A net is a plane figure that can be folded to make a solid figure. Another way to say that would be that a net is a two-dimensional figure that can be folded to make a three-dimensional figure. More than one net may form the same solid figure. In this example, we can see a cube that has been unfolded to begin creating its net. Once we've finished unfolding the cube, it may produce a net that looks like this. Here are two other examples of nets of a cube. Can you visualize how folding along each line will create the cube shape when you're finished? Try these two practice problems with nets. In number 6, copy down this figure. Then add one more square to turn it into the net of a cube. This can be tricky, especially if you're not a visual thinker. We will do some practice tomorrow with folding paper nets so that you can begin to develop the skill of seeing it in your head. For now, give it a try, and if you get stuck, don't worry. We'll practice more tomorrow. For number 7, visualize folding up this triangular shape and tell me what three-dimensional shape you're going to create when you're done. Press pause while you work, and there's one final practice problem for Chapter 14.1. This last practice problem is really tricky, especially if you don't think in pictures. Number 8 shows the net of a cube. You're going to fold that cube up in your head and then label the vertices. Whew! So, if you look at the cube shape that's off to the right, you can see that point F, point G, and point C have been labeled for you. So here's where they would match on the net. That means, I'll help you out a little bit here, that this vertex would be B. All right? Now, can you figure out what the labels would be for the top plane? Do your best. If you can't figure it out, no worries. We're definitely going to go over this together tomorrow. Think of this as a logic puzzle rather than a math problem, and that might help you figure out some techniques that you can use to solve it. All right, thanks for your hard work on these new ideas today. I'll see you tomorrow for more work with our prisms, pyramids, and nets.